This video is going into 7.6, problem number 13. I got a question about it. The question says, can you explain this one to me a little further, please? Thanks. So it says, a woman can bicycle 88 miles in the same time as it takes her to walk 32 miles. She can ride 7 miles per hour faster than she can walk. How fast can she walk? Okay, remember our overall goal here is to not panic because no one is expecting you to know exactly what to do right from the beginning. Instead, we're going to either recognize the problem as something that we already have a pattern to use, or we're going to translate it into English or translate it from English into math so that we can work with it. For me, it's talking about two different rates, like she can ride some number of miles per hour faster than she can walk. So I'm going to write down a fact about the two rates. So I will say she can ride 7 miles per hour faster than she can walk. So I would say that my riding speed is 7 miles per hour more than my walking speed. Notice that I'm just writing down true facts, but here I'm focusing in on the rates, the speeds, and focusing in on writing down something about the rates should help me organize what's going on in the problem. So let's go back to the question. It says she can bicycle 88 miles in the same time it takes her to walk 32 miles. Okay. Bike 88 miles. Walk 32 miles. Okay. Well, I don't know the biking speed, the riding speed, and I don't know the walking speed. This does tell me the ratios between them. What does the question want at the end? How fast can she walk? So this is what we want. So I guess I'll say that the riding speed is 7 plus x. I'll let x be the walking speed because that's what we want. Okay, what else does this tell me? This tells me that the biking speed, that if I do biking over walking, I can do 88 miles biking in the time it takes me to do 32 miles walking. So if I put all the bikings on top and all the walkings on the bottom, maybe it looks like this. And while you're watching something like this, what I want you to see is that I'm kind of not afraid of the fact that I'm floundering around here. I tried to organize all the information, write down some true fact, figure out what I actually want, call that X, and then if I'm stuck, try to use some tool that I remember. And the tool that I remember that I came up with was the proportion one. That as long as I put biking on top and walking on the bottom, that I'll be okay. The walking speed has a name. The walking speed was called X. So I guess I can find what the riding speed is. The riding speed, by multiplying by x, I'll get 88 over 32x. If I take that, this fact, and combine it with the fact I had before, then I think I should be able to get an equation I can solve. So the riding speed is 88 over 32 of the walking speed. The riding speed is also 7 plus the walking speed. And now I have an equation that just has x in it and not any other stuff. So then I can solve it. If I take away an entire x from 88 over 32x, it's a little bit awkward, but one way to write an entire like 1x would be 32 out of 32 x's. Then when I subtract them, I have 56 out of 32 x's. So I can get x. X is 32 out of 56 times 7. Ask my calculator what this is. Wait, do I need to ask my calculator? Hang on, wait, 56 cancels with 7. 56 cancels with 7, leaving behind 8. And 32 cancels with 8, leaving behind 4. So the final answer is that this walking speed is 4. 4 what? 4 miles per hour, I guess. Yeah, really the 7 was 7 miles per hour. 7 miles per hour, 7 miles per hour, miles per hour. So in the end, I did have 4 miles per hour. I don't know that that's particularly like, this isn't a very clean solution. Like this didn't go from point A to point B directly. It kind of went from point A into a maze where we walked around not knowing which way to go, and we were okay with it. And then we eventually ended up making it to point B by remembering a way to write things, a way to deal with these things, which is to write them as a proportion. Okay, I hope that's helpful. We'll send it to you.